number 73. We have 0.95 grams of water, and we have 75 gram block of iron. All right, and this water is condensing. So that means it's going from a gas to a liquid. That's a weird L. Liquid. Gas to liquid. Right? And that iron is initially at 22 degrees Celsius. Right? If the heat released during condensation of the water, so right when water goes from a gas to a liquid, it releases heat. If that heat only goes to warming the iron block, what is the final temperature in degrees Celsius of the iron block? Assume a constant enthalpy of vaporization for water of 44. So that's delta HV. Now, there's a couple things we have going on. Alright, I'm going to have an iron block. Iron block, and it's 75.0 grams. It's 22 degrees Celsius. And we got some water now on this block. Condensing. It's starting to condense. Alright? I'm just throwing a big drop. But it'd be more like, sweating, right? When a drink sweats, that's what it's going to look like. Alright? And so this is going from a gas to a liquid. Alright? So the water has some heat, and the iron has some heat, right? So the Q's are going to equal. So the Q of water is going to equal the Q of iron. Except who's losing the temperature? Well, if the heat released from water is going into iron, right? And so right, we know that the water and the heat. Now, you can do, and maybe you've been taught this way, the absolute value of both is the same. Right? But the heat released by the water, I'm going to delete those, is equal to the heat gained by the iron. Now, one thing we have for the water, all the water is doing is condensing. It's not doing anything else. So all this water is going to do is condense. The iron is going to warm. Alright, so we look at water. I can do water independently here. Q, the heat released from the water, is going to be equal to delta H, in this case, V times the amount of water. Right? That's all it is. Okay? The iron is going to warm. So Q equals MC delta T. Now we're looking for delta T. We got the mass C. We're going to have to actually look up C. Now, if you look up C, it's not in the appendix of your textbook. It's kind of weird. It's in the middle of the textbook. Right? And so we talked about this in current edition of TRO. It's in chapter 9. It's in the thermochemistry chapter in the first part of the book. So there's two like thermochem chapters. There's the Chem 1, right, which in this case is chapter 9, or currently it's chapter 9, and then there's the thermodynamics chapter that we'll cover in this course later on. So this is actually in the chapter. If I look it up, it's 0.449 joules per gram degrees Celsius. And it's right where you look up specific heat. So if you're in the e-text, look up specific heat, and it's right around. It's on the page or two, plus or minus, right there. All right, and that's a good, that's how you can look things up in the book. Definitely use the book number for that. All right, so Q, we're looking for this energy, is equal to delta HV. Now our problem gives us delta HV is 44.0. 44.0 kilojoules per mole. And we have 0.95 grams. you guys are probably quick enough to realize that we don't have, or we have grams and we have moles, and they do not cancel. However, we know water, right? We know that there are 18.02 grams of water in 1 mole of water, right? So that's molar mass. Okay, H2O. And so moles now cancel, grams now cancel. I'm left with kilojoules. So Q is equal to 44 times 0.95 divided by 18.02, which is 2.32. 2.32 kilojoules, or 2.32 times 10 to the third joules. Either way, so that's how much heat is released. Now, technically, that's a negative number, right? But just with energy, just like money, the sign has to do with direction, not value. So it's being released. So now I'm going to go back up to the iron. I get 2.32 times 10 to the third joules equals the mass of the iron, which was what? 75 grams. The specific heat of iron was 0.449 joules per gram degree Celsius. And then I'm just going to throw in delta T. What is delta T? So if we do that, all right, do the math there. 2.32 times 10 to the third, divide 75, divide by 0.449. I get delta T to be 68.9 degrees Celsius. Alright, so now that's the whole change. We started at 22. Right? So delta T, we gain 68.9 degrees Celsius. If we start at 22, and is it just 22? Yep. So we're going to make this degrees Celsius. So I'll make this 69 degrees Celsius plus 22 degrees Celsius to be a grand total of 91 degrees Celsius. And there would be our answer. So what did we do? We found out how much energy the water released, and then we found how much energy we know how much energy the iron absorbed, and we figured out the change in temperature. We added the increase in temperature to the starting temperature, and we got it. So that is 73.